Hello, everybody. My name is Nicola Tomatis. I'm the CEO of the company BlueBotics, and I'm very happy to be here at the DC Velocity booth at the BOTEX to present some of the successes of our customers. It's a great opportunity to be back to the MODEX this year after 2 years that were quite complicated, and it's really incredible to be back there and face-to-face meeting with customers and prospects. So thank you very much for this organization, and thank you very much to DC Velocity to give me the opportunity to give this presentation. Today I'll be talking about three projects that our customers have realized. Ourselves, company BlueBotics, we are supplying a navigation system and fleet management to vehicle suppliers. So our vision is to be the reference in autonomous navigation, while our mission indeed is to help companies to go through the challenge of vehicle automation. So our company is 21 years old, and our customer have installed more than 3,000 vehicles around the world. We assess the systems to be more than 1,000 because we don't even know right now. Our customer doing all the work. And we have calculated that the vehicles using our technology did more than 10 million kilometers. Now let's dig into the topic of today. So we have three examples of applications that have been implemented using our technology. Again, we are, let's say, just the technology supplier. The work has been done by our customers, the vehicle suppliers, and the integrators. We start with an application in auto parts production in the USA. So the company is called Jacom Corporation. Indeed, they are in the automotive. They have 630 employees, and they have installed 5 AGVs from the company F3 design in the Netherlands. The model is called Nipper. And they have used our fleet management to integrate with their own, let's say, warehouse management system, the Ignition SCADA system. The goal, let's say, the challenge for them was to optimize the use of resources, especially headcount, and they were basically analyzing their own plant and realizing that there were some inefficiencies there, and that's how they approached the project in order to optimize efficiency and costs. Basically, they have to move around parts in the warehouse, and this is about tubes and raw materials that go from the warehouse to the assembly. They were working before that with manually driven vehicles, and that was quite complicated because they have a lot of movements in there, and they have quite slow delivery because of that. And so they had to go through an analysis of the let's say, processes in order to find out what was the best solution for them. And they had one big constraint, which is that the space they have is very limited. So that's why they had to find the right solution for their automation in this plant. And the right solution turned out to be indeed the F3 design Nipper vehicle, which has a capacity of 1,000 kilograms, let's say 2,200 in US metrics. It's a very compact vehicle, and as the responsible of the project said, as soon as they saw this vehicle, they thought that's the one they need for their application. In terms of software integration, indeed, they used the fleet management that is provided by us as a technology supplier in order to interface with their SCADA software. And they have developed also a dedicated interface for that. This is a typical setup that they have. So you see that there is a very limited space to move around. It will not be easy, even with a typical pallet jack. It will not be easy or even not possible to pick up this kind of payloads. Then this vehicle has also the specialities that it can move in an omnidirectional way, so it can correct sideways in order to pick up a pallet. they use the functionality that we provide, which is that they can search for a pallet, so that if you have a payload or a pallet which is placed manually and maybe not exactly where it should be, the system can search for it, find it, and pick it up. Now, don't want to spend too much time on the videos, but the result of that is that they could reduce resources of 72% in this process, and they had a return on investment, or let's say a break even, after 2 years. And in the next phase, they want to automate another process where they need a rich track vehicle, and they are now discussing with different suppliers, using our technology in order to make sure that they can put this kind of new vehicles together with the others one in the same, let's say, in the same fleet management system. The second example I would like to show you is a complete different setup. This is automation in semiconductors. So one has to know that semiconductors is probably one of the most, if not the most, complex production process that exists in the world. So the customer there is ABB Semiconductors, which has been changed to Hitachi Grids recently because it has been acquired by Hitachi. So the industry indeed in semiconductors, high-tech, they use 14 small vehicles, and there, same thing, they were using the fleet management provided by us as a technology supplier, and they have interfaced this to their own manufacturing execution system, which is called ABB Ability Manufacturing Operations. So the goal was to increase efficiency to remain competitive. So this plant is in Switzerland, and labor in Switzerland is very expensive. So they had no choice to either automate or stop production in Switzerland and go somewhere else. So the goal is indeed efficiency, but it's much more concrete. If we want to keep production in Switzerland, they had to automate, and this is the same happening in US and in most of the developed European countries. The task is to move semi-assemblies from one machine to the other to indeed implement this very complex semiconductors production process. In this case, it's an exception. We have developed the vehicle ourselves because our customers were not able to do that. Now we collaborate with our customers for this kind of applications. And another constraint was that the vehicle have to move in a clean room, ISO 5 environment. So there are also a lot of constraints in terms of clean room compatibility. As you can see here, the semi-assemblies are moved on some carts on one side and on other sides on trays. So there are 3 different types of vehicles doing that, and they are moving then these parts between indeed some machines and other production machine, or in this case to bring them to the test facility system, which is completely fully automated. The main idea there was to move from the 100 people manual semiconductors production to a full automated one that can run 24/7. There, the result is then that there is a significant productivity increase. I think that the customer didn't want to disclose how much it is because it must be huge. And so they have also an announcement of the quality. They won several awards, and the big point is that they could keep the production in Switzerland, which means that indeed they have reduced their headcount to stay in Switzerland, but they still keep 200-300 people around this facility to make everything happening, which would not be possible without automating. The third example we have, again, we got in a completely different topic. Again, it is automotive like the first one, but that's now not about tier 1 component supply. It's about tire production. Tire production is a quite, let's say, old industry, and it has not been automated as much as the automotive, let's say, car production market, and so there is a lot of to do there to be competitive today. In this case, we have a very specific challenge that had to be solved. So The company is Michelin in Italy, in Cuneo. Indeed, they produce tires, and they have installed 6 quite huge vehicles simply to move all the tires they produce from the production building to the building where they prepare then to send via trucks to the different customers around Europe. The goal there was to improve cost efficiency and safety, because in the past all the process was done by manual trucks there, and indeed the goal was then to replace these existing manned trucks. As we say, the transport to be automated was to move all the tires from production to the warehouse, and it's a quite long. It's also 1 mile, almost 1 mile distance outdoor where this vehicle have to work, and they are moving more than 600 tires every time. As you can see here, the plant is quite impressive. You see that. Oh wait, it's not moving. Here we go. The plant is quite impressive, and you see this huge street going through all the plant is the one that was used in the past by the manual vehicles to move all these tires. I think they produce about 10,000 tires per day, and indeed these have to be moved from one side to the other of the plant by these huge machines. This is now a fully automated process which is running 24/7 in summer, in winter, in every season. And the result was then very successful. There are not so many AGVs working outdoor like this, so it was indeed a kind of milestone in the field to put this kind of machines outdoor to do this process. And for the customer itself, the goal has been achieved because they have an increased efficiency, of course a cost reduction, better safety, and also quite important impact in terms of ecological impact, because they have reduced the CO2 creation of 50 tons per year. These were the 3 different applications we wanted to show. As we said, BlueBotics is an independent generic component supplier that delivers navigation systems for any kind of vehicles and applications. So now I'm happy to pick up questions if you have, and because I'm finished with the presentation. So thank you very much for this presentation and for giving me the opportunity to show some of the examples of what our customers do with our technology. And thanks a lot also to DC Velocity for giving us the opportunity to show this presentation to all of you.